what we're talking about is achieving Zen-like bliss with glance. The idea being that everybody uses glance, because you pretty much have to in OpenStack, but not everybody really uses glance. And so we want to give you a few pointers at how you can use glance to make your life easier. And that's what we'll do. All right, my name is Brian Rossmeda. I'm working for Verizon Wireless these days. I'm the PTL of Glance, and I've been working on the Glance project since Folsom, I guess.
And I'm Erno Kuvaja. I'm working for Red Hat. Have been working with Glance since, I think, Icehouse.
Yeah.
So
it's been a while.
It has.
Okay, so Erno's a core contributor to Glance and has been around the project for a while. So we kind of know what we're talking about, is
hopefully
the point. All right, so just about what Glance is. So it's the OpenStack image service, and the code name is Glance, and I don't know exactly what the genesis of that was. But the service itself is maintained by the Glance project, of which we're members. And the basic idea behind Glance is that it allows you to store, browse, share, distribute, and manage bootable disk images so that when you want to create instances with Nova, you can do that. And the Glance software provides image service APIs. And currently there's 2 versions. Version 2 is the one that's under active development, and version 1 has been deprecated for 2 cycles and is scheduled to be removed in the Queen's release. So you can look forward to not having to worry about having version 1 around anymore.
Yeah.
And I just slapped a quick link on there if you want to look. There's an API reference guide to the images API that basically explains what the calls are like and gives you some background on how to use it.
The project also provides the Python Glance client library and the Glance store library. So all of these 3 repositories are under the Glance project umbrella.
Right. Okay. All right, and then we've got some more Glance talks in case you're not satiated by what you get today. So there's an operator's feedback session tomorrow at 4:10. And that's sort of a general format. I have some particular items I'd like to get feedback about that I'll talk about, but it's also a general format thing. If you have any concerns you'd like to bring to the attention of the Glance team, it'd be a good time to show up and do that. And then there's a project update where we're going to be talking about what got delivered in Pike and what we've got prioritized for work in Queens that we've begun work on. And then Erna's going to be leading a session on the last day at 4:30 about the Glance interoperable image import process. So that was introduced in Pike. That's what just came out, right?
Yes.
So it's introduced in Pike as an experimental API, and we're going to finalize it and make it the actual full API in Queens. Okay, so what I want to talk about, so these are the things that we sort of identified that would be useful for people to know about when they're running Glance. So one thing is just discovering images so that you can find the ones you want to use. Another one is how do you share images effectively with other people in your organization. There's also the ability to put custom image properties or metadata on images. These can be protected with a feature called property protections. So I want to talk about that a bit because I don't know that that's utilized as much as it could be. Then I want to talk about the digital signature validation that's available in Glance. And then we're going to touch on what are image locations and whether they're appropriate for your cloud. They're a feature of Glance that's been around for a while, but we'll talk about why they might not be appropriate for most clouds. And then we'll talk real briefly about the new image import workflow because we've got the full session on that on Wednesday. All right, so the first thing, how do I discover images? So with Glance, we have what's called the image list call, and it's just get v2 images. So there are a few configuration options that the operator can supply. So there's the size of the response that someone would get if they don't explicitly ask for a particular amount in the response, and it's 25, just so you're aware. And you can also set a maximum of what's the maximum number of image entities that would be returned in an image's response. And then that maximum is applied no matter what the user specifies. I'm just bringing this up because sometimes people just look at the image response and think there are a few things missing, not realizing they just need to page through, or just need to request more if they want to see everything at once. Now, the end user can supply a limit as part of the query string with this request, and then that's honored unless it exceeds the limit max, and then the limit maximum is what the person would get. The key thing I wanted to bring up about the discovery is that the default image response does not contain all the images that are available to the end user. And I'll talk about why that's the case. It's mostly because it's an anti-spam feature. But I want to bring it up because what we provide in the default image list response is what you're probably interested in. And then if you're interested in other stuff, you need to make some more queries. But the key thing is it's not, the way we've got this filtered is it's not you get everything by default and then you narrow it down. What we try to give you is what makes sense by default, and then you can ask for more if you need it or narrow it down if you need it. Okay, so the key things to know about the default content that you would see. So if you don't include any query parameters other than the limit or a sort order, you're going to see all the public images regardless of who owns them in the cloud. You'll see all the private images that you own. You'll see all the community images that you own. And you'll see all the shared images that you own. And then you will also see all the shared images that you've accepted. So that's a lot of stuff, right? So what's missing? So what's missing is community images that are provided by other owners. I'm going to talk a bit in the image sharing section about what exactly community images are. But the basic idea is it's an ability for people to just sort of publish images that other people can use. And with that ability comes the possibility that people are going to publish spam images and all sorts of garbage that people don't want to see. So that's why we leave those out of the default response. And then shared images that haven't been accepted. Image sharing is a great feature, but it's also prone to being misused by people who want to spam other people. So we have a way to make sure some images don't show up in the response.
And good reminder for this is these are images you are able to see and consume. So this should be something you can boot. But this is not the list of images you own and you can go and modify. So there is a distinct difference there, that what you can consume and what is actually owned by you and modifiable by you, as in metadata.
Yeah, that's a good point. So in the default response, you basically get all the stuff that you can boot or create
volumes out
of, but you don't get everything that you have the ability to manipulate. Okay. And then in order to discover those missing images, how do you do that? So you can add the visibility feature, the visibility filter. And so it's just visibility equals, and then you just provide the identifier for which particular visibility you're looking at. So if you ask for visibility equals community, then you will see all the community images, including the ones that you own. And then you can narrow that down by specifying which particular owner of images you're interested in. Because with the community, the idea behind the community images is that there's this big cloud ecosystem and lots of people are publishing images that people might be interested in. And you may, with community images, right, you have to basically, the question is, do you trust the person who's created this image or not, right? So there'll be particular image producers who you trust. So you would use their IDs to figure out who they are and to see only the images that they supply. And then if you just want to see your community images, the ones that you own and have produced for other people to use, you would use your own image identifier for that. So,
and per default, the community images are, after all, created by users that the cloud provider trusts. So there is a difference between shared images and community images, as anyone can share images, but publishing them as a community images needs by default approval by the cloud operator. So you have that kind of dual level of trust, so that the cloud operator trusts the image provider, and then you can still narrow it down for those that you really only trust, or if you want to trust the whole bundle of the community images.
Right. I think we'll talk about that a little bit more in the shared part. All right, and then to look at the shared images, just visibility equals shared. That'll show you the ones that you own and that you've accepted. And then you can also attach an additional filter to see all the images that have been shared. Or you can just look at the pending ones, or you can look at the ones that have been rejected. It's pretty much up to you what you'd want. Now, the other interesting thing about the image list call is that you can basically filter on any image property. And those tend to be subject to local practices, what they're used for, what the values are, what their names are. There are a set of properties called the common image properties, where we've tried to provide a mechanism where clouds could standardize on particular things like what operating system's on an image and what version. But that's we don't have a way to enforce that. So it's pretty much up to operators to adopt that. The other limitations in doing image discovery is that the API really only allows conjunctions in query strings. So you can't do any kind of negations. So it limits the way you can search for things. There's an in operator that was introduced in Mitaka that does allow you to specify a list of things, and then you can get the results that match one of the items in the list. And that can be useful. The other thing is the name filter specifies an exact match, not a fuzzy match. So it's sometimes counterintuitive when people are using the name filter that they don't get results that they expect. So why do we do it that way? Why don't we just improve the API? Well, the problem is there's another project called Searchlight that basically allows Elasticsearch to be used to search any of the OpenStack resources. And Searchlight also consumes notifications, so it keeps the index up to date when changes are made to various items. So that would allow you to, and there's a plugin for Horizon for Searchlight, which allows you to do fuzzy searches and to search by name and to do all that kind of stuff. So we've decided not to re-implement that kind of thing in the images API because it's available somewhere else.
They just do it so much better than we would.
Yeah, right, because we would do our best, but it wouldn't quite be the same thing. And then finally, there's the size comparison filters. So you can specify either a size min, and then you'll only see images that are larger than that, or probably more useful, a size max will only return images smaller than that if you're looking to save money by using a small disk or something. And there are also time comparison filters can be applied to created at and updated at to help you narrow down the range of things you're searching for. So those were introduced to Mitaka, and the API reference explains exactly how to handle those. So that's basically it for discovery. And then let's talk about image sharing. So the question is, how do I share images effectively? And then it really depends who you are and what exactly you're trying to do. So sharing in the general sense just means to make an image available to somebody other than the owner. So in Glance, who can access an image is tied to the visibility property of the image. And we've got 4 values: public, community, shared, and private. And the way to change an image's visibility in Glance is to do the image update call, which is the patch call for HTTP. And you can also specify the image visibility at the time of image creation. So the default is shared, and we'll talk a little bit later about why that makes sense. And the ability to share in any of these ways is governed by policies. So as Erna was saying earlier, you have a way to, and I'll talk real quickly about what the default settings are. So you have a way to narrow down who can share, and because, right, it's a great feature because it allows collaboration to occur, but it's kind of a dangerous feature because it opens up the ability for people to do nasty stuff. So you do have the ability to control who can do this. All right, so with public images, a public image is just one that's available to all users. So the only person who can actually update or delete the image is the owner or a Glance admin. but any user can actually consume the image. And so the policy target for that in the policy JSON file is just called publicize image, and the default is the admin. So basically, the idea behind public images is that they're provided by the cloud operator. Usually, they have some kind of warranty or support relationship where, if there's a problem, a user runs into a problem trying to use the image, the operator will respond to it and try to make sure that's addressed. Usually, the operator is keeping these things kind of up to applying security patches so that when you grab a CentOS 7 or something, it's already been patched. So two things. If you adjust the policy, you can open it up so that anybody could create public images. Of course, you most likely don't want to do that because in most clouds, public images are used to distinguish the ones that the provider supports and the provider recognizes as being good images to use. So you can break that if you want, but it's probably not a good idea. And there's really no reason to do that because we have community images.
Well, there is the reason to change that from admin because the value being default by admin, it actually really means that it's the cloud admin. So lots of bigger organizations where you have a big team operating the cloud, you might want to actually have just a subset of that team to handling those images. So you can create a specific role like image admin, and at that point it would make sense to change that. But it's really more limiting so that you don't need to grant the whole cloud admin role for the person who is just responsible for the public images.
Yeah, and that's a good point, and that's why we have it governed by a policy.
Yeah.
So it makes it loose. So my main point is good. My main point is really just
you don't want to make it allowable for all.
Right. You could, but
cases.
you really don't want to do that. And we also have community images, which are also governed by a policy target. So it's communitized image just to be on the same page as publicized image. But that one's empty in the default file, so that means anyone in the cloud can do this. So you may want to review whether that's a good idea or not, depending on your cloud. But the idea behind the community images is just that it's an image that maybe an open source project or something has made, and they would like a lot of people to use it, and they're willing to maintain it and offer support for those people. And so that's kind of a nice thing, so we want that to be available. So it's, as I say at the bottom here, it's useful if you want an image to be available, but you have no need to know who exactly has access to it. So for instance, if the CoreOS people were doing this in the Rackspace cloud, they wanted their operating system to be available, so they were willing to, willing to create an image that had all the stuff so that you could use it effectively in the Rackspace cloud. And they didn't care who used it, they just wanted to make sure it was used. So that's the idea behind that. And then finally, what we're usually technically called shared images are images that are made available to specific other users in the cloud. So people have to be made a member of an image, and then they have access to it. So the way it works is that only the owner or an administrator can update or delete the image. So even when you shared it with somebody, you're allowing them to have access to it, but they don't have control over it and they can't update it. So only the owner or the admin can add or delete image members. So you can't add yourself to an image. But only the member or an admin can change the image status. So this is the anti-spam feature. So the image producer will share it with you and by using your tenant ID, but only you can modify your status. So by default, when an image is shared, it's created in pending status, and those don't show up in your default image list. So if you accept it, then it will. Now, there are associated policy targets with this, which are perhaps a little bit overkill. So you can control who's able to add a member, delete a member, get a member, list the members on the image, or modify the member. But that's subject to what I said earlier. I mean, no matter how you modify this policy, you can't make it that somebody who's not a member can change somebody else's member status. So this has to do with who can make the API calls that allow this to happen. but only in the context of an image to which they own or if they're an administrator. I don't know if that made any sense, what I just said. But the basic idea is, with all the policy targets in Glance, there's some basic expectations for who can use an image or who has control of it. And it's usually just the owner and an administrator. And so you can modify. The point of the policies is that you can create different rules, and you can assign roles to people. So some people can be observers, and they can look at stuff but can't change it. Some people have the ability to change it, but maybe only for non-destructive things. And then some people have complete power to just manipulate images. So this will allow you to do that. But as you can see, the defaults are just wide open so that anybody can do this.
It's a good idea if you are planning to change those values to actually dig in and try to understand them. Because, for example, if you block a normal user modifying the member, the other user can go and add you as a member, but you cannot accept or reject that image. It may cause kind of deadlock situations where you suddenly have a different kind of state that you just cannot get out because as an operator someone blocked you to do that specific call. So it's one of those things that don't start messing around too much unless you understand what it will actually affect. So what you can do is basically if you want to disable, for example, image sharing in your cloud, you can go and just deny all of these actions, and that will basically just block image sharing. But don't go and start doing one-by-one changes there without understanding the implications of those.
Yeah, that's a good point. I mean, it's just, you have a lot of flexibility, but that makes it difficult to get it right. So the defaults for most of this stuff are good. Just want you to be aware, the default for being able to create a community image is we let everybody do it. That may or may not, depending on your situation in your cloud, you may want to adjust that one. Other than that, I think the defaults are pretty good on these. All right, so how do you share images effectively? So an image has to have the shared visibility in order to have members added to it. Now, simply having the shared visibility does not imply that anybody other than the owner has access to the image, because they actually have to be made a member in order to be able to see it. So in addition, so if somebody else is going to have access to your image, it's got to be, the visibility needs to be shared, and it's got to be the case that they're actually a member. So if you have an empty member list, then even if the visibility is shared, nobody else is going to see it. So just something to keep in mind, because the default visibility is shared, which seems kind of weird, but we had to do that for backward compatibility with version 1 API. So yeah, I think that's all I need to say about that.
Yeah, so that actually came in with the same time as the community images. So okay. It's a good to remember that this actually changed quite recently, and it's showing up shared now while it was before the visibility was just identified as a private, and you had to actually go and see the member list if the image was actually shared or not. So right. So the shared image status is fairly new as well, and it might be something that some of you might actually just stumble upon recently after upgrade, and it's nothing to be actually alarmed about. As long as you don't have members in the list, no one else will see your image still, even it's showing up as a shared.
Yeah, I'm sorry. I always forget that people aren't like completely up to date with the latest version of Glance and OpenStack in general. So yeah, so in Okada we changed this. Previously there were only 2 states of visibility, public and private, and that applied even though image sharing had been implemented earlier. So we made that more clear when community images were available, and that's why there are 4 visibilities now. And I think things behave much better in a more logical way. So hopefully that's good. So the key thing is that shared images are useful if you know which people you want to have access to an image. So it was originally implemented as a way to have an image marketplace where individuals could produce images in a particular cloud and then maybe sell services to other people who wanted to consume them. So that's why there's this one-to-one relationship. So you know who's consuming your image, so you could support it if you needed to. But the key thing is that as soon as somebody's made a member of an image, they have access to the image, whether they've accepted it or rejected it. So accepted, rejected, and pending just have to do with whether something shows up in the default image list response. Actually having access to the image, a member has it as soon as they're created onto the image. Okay. How can I make better use of my image metadata using property protections? So property protections were introduced in Havana, so that's quite a ways back. And basically what they do is they allow an operator to be able to specify create, read, update, and delete on specific image properties. And the request for this was because for licensing of particular images, if you handle that kind of thing in your cloud, you need to be able to make sure there are particular metadata items on an image, and you don't want the customers to delete it. A case in some clouds is if you have a Windows operating system image, when somebody creates an image from that base image, you know the properties there you own it. But if somebody creates a snapshot, what happens is that they're now the image owner, and so they could delete that property that you need for bookkeeping purposes, perhaps. So property protections give you a way to specify what metadata people can have access to on an image. And at this point, they're called property protections instead of protected properties, because it's not a particular kind of image property. These just apply to any of the custom image properties. It's just like a layer of authorization around the custom image properties. And in the configuration, you can either use just a list of roles that people have to have in order to be able to do this operation, or you can use policy rules to do something quite complex to specify what it is, who has access to the particular properties. And we've left it up to the operator to document how properties are set in the cloud. There's no way for a user to find out other than the operator telling them somehow. So I'll mention this. It's mentioned a couple places in the API reference. Okay. And it's just something to be aware of. Okay. So the configuration, the related options, in Glance, by default, people can add additional image properties, but you could also turn that off. So of course, if you turn that off, then people can't add any image properties, and so then there's nothing to protect. Another thing to keep in mind is that there's an image property quota value. So it's quite large as a default. It's 128 in Glance. Just want to bring it up. If you open things up so that people can add additional properties, you may want to make it bigger or smaller. Just something to be aware of. And then the way that the property protections work, there's a property protection file, and the default is an empty string. And the way you turn on property protections is to specify a file name. And then there's a property protection rule format setting that basically tells Glance what to expect to find in the file, whether it's going to be roles or rules that it can use. And so it's roles or policies is the setting name. So basically, if you specify a property protection file, it covers all your custom image properties. And the feature is very conservative. And what I mean by that is if the file can't be found, the API won't start. If there's a problem with the file content, like a malformed regular expression or something, the API service won't start. And if a property is not mentioned in the file, the permissions are just deny all for that property. So it's extremely conservative. So because of this last one, you probably want a catch-all at the bottom if you want people to be able to create. Depends on what your use case is, what direction you're trying to take this. But if you want people to have access to image properties except for particular ones that you've named, you would put the catch-all to allow that.
It supports wildcarding, so you can do really powerful things in there, and for example, only allow users to specify a properties with certain prefix or anything like that.
Okay, great. And the file itself is roughly in the INI file format. So each of the protection clauses appears in square brackets, and it's a regular expression. And then it's followed by 4 key value pairs for create, read, update, and delete, an equal sign, and then each either the list of roles or the particular policy rule that governs how that's used. Then the file is read by glance top down, and the first match wins. And then, as I said, the feature is very conservative, so if one of the keys for create, read, update, or delete is missing, then the API will refuse to start. So it was done that way just so that you know for sure that this is either working or it's not if you turn it on. Okay, so just a couple of hints to using this thing. The protection descriptors are regular expressions, and as you know from if you've worked with regular expressions before, they're extremely powerful, they're extremely handy, but they're really easy to get wrong. And it's just sort of the way it goes. So for instance, very protected as a name is going to match very protected, but it's also going to match a bunch of other stuff because it's treated as a regular expression, not an exact string. So it would match some things maybe you wouldn't expect, like not very protected would be covered by this, very protected not, all that kind of thing. So probably what you'd mean would be to use the regular expression to anchor it at the beginning and the end and say this exact thing. So just something to be aware of. The other thing, as Erno pointed out, some people will use a prefix to protect an entire class of expressions. And this is probably a good way, because it'll make it easy to explain to your users. It's like com my cloud, right? You can't use that to name your metadata because I use that. So the way you would protect it is just you have to put the anchor for the beginning and then com. And then something that's easy to forget is that a period as a regular expression doesn't just represent a period, it represents any character. So if you don't put that backslash in, it will protect com.mycloud, but also a whole bunch of other stuff too that you might not anticipate. So anyway, just something to be aware of if you do that. Okay, and then of course, right, the dot asterisk at the end, if you just put an asterisk, you're going to have a problem because it would match the D, not anything else. So anyway, it's really important if you do use this to have tests in place to make sure that you protect the stuff you want to protect and you aren't protecting stuff that you don't care about. Just be aware. Really nice feature, but it's easy to. We tried to make it hard to misconfigure, but of course it still is. Okay. Just a hint from having done this in a cloud, the rules are great because they allow you to specify really complex expressions to protect things. You'll probably want to have just particular rules just to govern the property protections that are different from the rules that govern the other stuff that you're doing in your policy file. You don't have to, but that's probably a good practice. And then the way the property protections affect end users is that if they try to do an image create or an image update and specify a property that they're not allowed to create, they'll get a 403 forbidden, and then the error message is just attribute, and it will repeat the bad one is reserved. And that can be quite annoying if you're trying to create an image, and especially if you specified a whole bunch of things, and just one of them is incorrect. So that's why I mentioned earlier, it's really important to try to come up with some kind of convention for how you want to use these things and make sure your users are aware. But if you look at property protections in the Glance admin guide, you'll see a lot of stuff about that. All right, and I'm going to go through this really fast because we're running low on time. Yep. So another thing is using digital signature validation of image data. Glance has had this since Liberty, and then it was redone in Newton to completely eliminate dependence on MD5. So it's a very strong feature. But it does require a bit of infrastructure. So if you're interested in using this, there are two good things to look at. One's the trusted images section that's in the OpenStack security guide that gives you a basic outline of how this works. And there's an image signature verification section in the Glance user guide that explains how to configure it from the Glance side. As far as setting stuff up, you have to have Barbican in your cloud because we need some kind of neutral place where the public key certificate is stored. And Barbican's the one that's available for OpenStack. So you would have to have Barbican running to use this. And then on the other side, the operator also has to configure, to make this useful, the person consuming the image needs to know to validate it. And in most cases, that's going to be Nova because you just want to make sure that you're booting an image, that the image data you get when you go to boot is actually the trusted stuff that you expect. So the operator has to configure Nova to do this. So the code's built into Nova. You just have to turn it on in the Nova configuration file. And then there's also work on the end user's part to make this happen. So you can turn image validation on, but not everybody has to use it. But if you do want to use it, you got to go through a bunch of steps as an end user. So you'd have to upload the certificate to Barbican so that it's there in that neutral location. You've got to generate the signature for the file, and then you've also got to supply a bunch of information as image metadata properties so that Glance and Nova can consume those to actually perform the validation. And what you have to supply is the certificate reference, an identifier for what signature algorithm is being used, an identifier for what hash method's being used, and then the signature of the image. So the way this works is that with the image data is hashed using a secure hash method that you can specify, and then the signature is created using a signature method that you specify. And it's done, and that's kind of a two-step process because we need to limit the signature to 255 characters because it's got to fit as image metadata. So just in case you're curious. And then the image, so the user's got to do all that stuff and then supply all that information at the time of image creation as part of the image record. And then what Glance will do is when the image data is actually uploaded, it will retrieve the certificate from Barbican, validate the image data based on those properties, and if it fails, it just deletes the image. Because we figure you don't want that hanging around if there was some kind of problem. And then that's pretty much all I have to say about that one.
Yeah. So that's actually, for the last slide still, one pointer of that is the last point there is it's really going to delete the image. So lots of the failures, what our normal failure operation is that we just delete the data and get the image back to the queued state so you can retry. With this enabled, it actually goes and deletes the whole image record, not just the data you uploaded.
Right, which is a little atypical. We had a really good reason for doing that, though, which evades me at the moment. But if you look in the Glance specs, you can see the original discussion.
But it's just something to notice that it behaves a little bit differently than we normally do.
Yeah. OK. And then image locations and whether they're appropriate for your cloud.
So yeah, I'm going to walk through this really quick as we are running out of time. But it's basically, it's a part of Glance API's way to track where the actual image data is, where your payload is. And it happens behind the scenes always, and we have API to interact with that. But that API is not really something you should expose to your end users. You quite often might need to expose it to certain users or certain services, but we noticed that exposing the image location data has lots of problems. There is a few security issues that has been filed against it. There is also the fact that it breaks the abstraction layer of exposing what backends are being used. And it also just provides the end user tools to do potentially really stupid or dangerous things with the image data. So it's just basically not a good idea to have on.
Yeah, I mean, the basic idea with the abstraction layer is just, Glance stores your image, and that's pretty much all you need to know as an end user. As an operator, there are various backends that are supported, and so you can put the data in the particular backend that you want. But there's no real reason for a user to know that. And depending on which backend you're using, sometimes it's not a good idea for users to know exactly where the stuff is because they may feel compelled to go mess around with it. And that never ends nicely for anybody.
So the question is then, why do we still have this feature? Why do we have that API? And there is actually legit use cases for it, like Glance and Nova sharing Nova ephemeral storage with Glance image storage on a common Ceph store. And at that point, Nova really needs access to this. And the other good example is that you as an admin want to move your images from backend store A to backend store B without affecting your end users. You want to be able to move the data and tell Glance that, hey, you can now find this data on the new store. And again, that's something you don't want your end users to do or need to deal with. The end user should need to deal with only the fact that I have image ID, I want to boot it, or I want to make make a volume out of it.
Yeah, it's pretty much the only way to seamlessly migrate data from a backend without your users knowing anything at all, because you can configure, when you have multiple image locations, there's a way you can configure which one is actually used when somebody asks for an image. And so you can have a special glance that's set up so you can test everything out to make sure. Usually what you would do is duplicate the image to the second store. You'd have some testing done using a special glance just to make sure everything's what you expect in the secondary store. And then you can go back and just change the ordering that it uses to give the user the location that's actually used. And then you can go ahead and delete all the locations that aren't being used anymore. So it's kind of, I mean, you want to practice this before you do it, obviously. Yeah. But it is a good way to be able to do that. But you don't want to expose that to end users, as we said.
Yeah. So how do we deal with these special use cases while protecting our users and protecting our environment? The really only reasonable option is that you have a dedicated glance nodes. So if you're using the Ceph ephemeral storage combined with glance image storage on Ceph, and you want to have Nova able to do snapshotting, for example, you need to grant Nova access to these things, but you don't want to have your users doing that. What you do is you grab a glance node, you put that behind your firewall, you block your end users accessing that, and you have your Nova pointed to those specific nodes, and you are pretty much set. And you have the same situation with those admin use cases. You want to just have a glance node that is configured differently, and you can still, as an admin, access that. So we don't track any of these things on our database. It's really based on how your glance API node is configured. So you can have these differently configured glance nodes accessing the same database and providing those operations with different class of consumers. And that would be the best way to actually deal with that.
Yeah. So, and it's a good thing I mean, right, we do not store the configuration options in the database, and it's mainly for this reason, so that you can have independent glance nodes that can behave differently, but all share the same set of image data. And it can be, right, it's another one of those things. It's useful in a lot of ways, but if by mistake you configure one of them differently, it's going to behave different, and that can be a bug if you're not aware of it.
Yeah.
So you're aware of it. Okay. And then key thing, what's the new image import workflow that we're so excited about, and what will it do for you? So we're just going to talk about this real quickly. The key thing is Erno will give you the entire story about this on Wednesday at 4:30, and we'll go into it in great detail about how it works.
Yeah, but the base idea is it's going to be interoperable, it's going to be discoverable, it's going to be all what we have been fighting to figure out how to do this finally right over past 2.5 years almost. And we are on the stage where we have a POC as a experimental API you can enable on your glance nodes, and hopefully in Queens we will be stable and production ready with all the feature sets what we need to actually use it.
But just to sort of give you an idea of what's going on, the difference between the regular image upload process. So Glance was designed so that you could just basically store anything in it, and the real idea behind that was we didn't want Glance to be a roadblock for changes elsewhere. So if you introduce some kind of new hypervisor or something that uses some kind of new format of image, Glance doesn't really need to know about that. So Glance will just let you store anything, and you describe in the metadata what's actually in the payload. So that's nice in a lot of ways. It's very flexible, but as with everything, right, there's some downsides, and one is that it's so flexible you can put anything in there like a JPEG, which luckily would not boot. But you could also do various malicious type stuff if you were so inclined, and as we know, some people are. So with image import, the idea is that end users, instead of just uploading stuff to Glance and then administrators having to try to figure out what to do about that, with this workflow, the data is uploaded to a staging area, and that allows the operator to do whatever it is the operator wants to do with it, which could include nothing if you trust all your users. But it does give you the opportunity to do that, and then it becomes an image later. And what's made it so drag out so long was to try to figure out a way to do this, because different clouds are going to have different things that they want to check, and they're going to accept different kind of things. And we made an attempt to do this once, and it was so flexible that it became useless because it was completely different in every single cloud. So this way, there are going to be just a few precisely defined paths that you can take. The operator doesn't have to expose them all, but the idea is for interoperability, you'd expose at least one of these methods, and then it would work. But come to the talk on Wednesday to get the whole lowdown and understand exactly how this thing works.
Yeah, exactly. And I think we have So unfortunately, we are out of time for Q&A, but we will be around. Come and ask questions and talk to us. We'd love to hear the feedback, especially about the experimental feature now when we still can't fix it, and we are still implementing some of the parts. So we have if you pull out back the rest of our schedule, so we have the feedback session tomorrow, which is really important part of why we are here, to actually hear what you guys need and what is working, what is not working, what is important for you. Thanks for your time.